Started. Thanks everyone for joining. My name is Peter Bachfalushi. I'm a technical sales specialist with Global Test Supply. Thanks for joining our webinar with Global Test Supply University. Today's topic is acoustic lubrication with SDT ultrasound. We kindly ask that you mute your microphones during the presentation. Our presentation will last about 40 to 45 minutes, and then we'll have time at the end for questions and answers. We encourage you to ask questions anytime. Just use the chat function on the dashboard and I'll answer them towards the end. So we're going to get started. Today's webinar is presented by Alan Reinstra. Alan is the Director of Business Development for SDT International, a Brussels-based manufacturer of ultrasound solutions. They're comprised of hardware, software, training, and consulting. A 28-year commitment to ultrasound applications has seen Mr. Reinstra play a leading role in the development of ultrasound-based solutions in 5 continents. He's the co-author of Hear More, a guide to ultrasound for leak detection and condition monitoring. Alan, we're ready for you. Please take it away.
Book plug. Thanks so much, Peter.
That book ordered.
I know. Like I said, thousands and thousands printed, hundreds and hundreds given away. But it is actually a pretty informative book, and it's actually helped us gain a lot of traction and helped our customers too. Actually, it's interesting. Before I start the presentation, I'll say I can think of 2 customers. One of them is in Labrador, and the other one's in Brazil. And both from reading that book came up with a new application for ultrasound that none of us had ever thought of before. So that alone was justification enough for us to write it. So I'm happy to have done that. Thanks for the great introduction. And slides are up. Yep. So welcome everybody that's on. Thank you for joining us and me. And thank you to Global Test Supply for this opportunity to present in the Global Test Supply University and this virtual workshop. I'm happy to spend some time today sharing my personal perspective on rolling element bearing relubrication, the way it's done, and the way it's done sometimes correctly and most of the times incorrectly. And so I'm going to identify some of the problems I see with that. Not procedural problems so much, but more philosophical problems, because a lot of the problems that are rooted in lubrication start upstairs in the management offices. And of course, if I'm going to present you a problem, it's not very useful unless I also present you with some solutions. So in a very non-salesman's kind of way, I'll try to propose some solutions to the problems I'm going to present. So most of you already have an in-house lubrication program. And if your aim isn't for that lubrication program to be world-class, then it should be. And by world-class, what I mean is precision practices. But unfortunately, what I see is many of you still apply grease to bearings based on work orders that might be printed out by your CMMS. And it's actually not your CMMS. All your CMMS that is a tool to print that work order, but how that work order gets printed and how it gets scheduled is done by calendars and calculators. So what I'm talking about here is time-based relubrication. And that's not precision, it's not world-class. What it is it's basing the intervals and the quantities, the intervals between lubrication tasks and the quantities of lubrication injection based on best guesses. And so for the next 40 minutes or so, I'm going to talk about prescribing bearing lubrication based on friction and not fiction. A quick word about myself. I'll go over this quickly because Peter already gave us a great introduction. But SDT Ultrasound Solutions, we are the world's favorite ultrasound company. We measure that not just by the vast number of ultrasound instruments that we sell each year, but by the quality, the endurance, and the sustainability of the condition monitoring programs that we help our customers to implement. And our mission is simple. It's to provide solutions to help anticipate failures. to help control energy costs. And in the meantime, also improve the product quality and the production output while contributing to the overall reliability of your assets, because our customers are guardians. They're guardians of the assets. My work is gratifying, and I'm proud to come to work each day and do it. And I can't wait for tomorrow to come either. We have values just like everybody else. Our values are what propel us forward. And when the driving becomes difficult, we have to do a gut check. If I have some uncertainty about my decisions, if I'm not sure if what I'm about to do is the right thing for either myself, my company, my family, or my customers, I look and see if I'm checking the boxes beside respect, simplicity, and flexibility. And if I can check all three boxes, then I know I've made the right decisions for all those people I mentioned. I'm coming to you today live from Cobourg. Cobourg is a small municipality inside of Ontario, Canada, on the shores of Lake Ontario. It's my home. I think it's beautiful. And I think if you ever want to visit it, you'll think it's beautiful too. And I'll be an excellent host for you. So come and check us out. As Peter mentioned, our headquarters and our manufacturing, our R&D is all done in Europe, in Brussels, Belgium, the capital city of Europe. And we expanded our business a few years ago to India by opening a regional office in Kolkata, where we have 6 employees. And this marvelous city, if you ever get a chance to visit India, make sure you go to Kolkata, especially if you like food the way I do. They have incredible food, brilliant colors, and of course, ultrasound from the world's favorite ultrasound company, SDT. Today, we are going to take a look at the task of precision relubrication of rolling element bearings. It's my goal to help you look at this task from a condition-based perspective instead of a time-based perspective. I'm going to tell you a story based on friction, not fiction. My name's Alan Rienstra, Director of International Business Development at SDT. And in my career, which is actually 31 years now, not 28, all I've ever done is ultrasound. And I imagine that's all I'm ever going to do, because I can't think of anything else I'd rather do than to help condition monitoring grow and have the stature that it should have in our reliability initiatives. My personal love affair with ultrasound began in 1991. That's the first time I picked up an SDT 150, which is a relic of an ultrasound gun. It looked like an old, I should have grabbed one for the presentation. They're still in use today. It looks like an old brick phone from the early days of cell phones. And I took that SDT 150 and I listened to the intake valves inside the Perkins diesel engine of my dad's tractor. And it was a Massey 135, just like the one that we have in this video here. This isn't his, but it was just like that one. The next 30 years have been absolutely filled with amazing discoveries, new applications, some that I've come up with, most of which have come up with by our customers. And we just continue to develop new ways to use this jack of all trades, versatile technology. Today, my passion for ultrasound is going through a bit of a transformation. Now I'm putting my accumulated knowledge to work, helping people to get the most from a technology that creates safe workplaces, reduces unplanned downtime, eliminates waste, and helps create that elusive culture of reliability that we all want for our organizations. Machinery lubrication, and in this case, machinery relubrication, remains the single biggest factor affecting asset reliability. The most experts will cite that as much as 40 to 80% of bearing failures are rooted in poor lubrication practices. So we have to get this one proactive task right. And if we can get it right, we can contribute to a long, trouble-free life for our bearings. But most of us are getting it wrong. And when we get it wrong, we can expect unplanned breakdowns. We can expect continuing reactive firefighting. And reactive firefighting leads to safety risks, because when we're reacting to a fire, we're putting ourselves in stress. It means that we stop following recommended procedures, standard operating procedures. It means that we cut corners. What do firefighters want to be? They want to be heroes, right? They want a pat in the back, job well done. We don't want that. We want planned, proactive repairs. So reactive firefighting is one of the worst things we can do because it puts everybody's health and lives in danger. When we don't get lubrication right, we drain our resources. We drain our company's resources. We drain our human capital, and it leads to a culture of unreliability, low morale. And if you ask anybody who's ever tried to right the ship on culture, it is the single biggest mountain to move. If I can mix my metaphors between righting sinking ships and moving mountains, I think I just did. But it's the single biggest change quake to create inside your organization. And so here begins my story. And I like to start stories just the way I'd tell them to my kids. Once upon a time. Because once upon a time is a great way to begin a tale that recaptures our memories from days that seem long ago and forgotten. But it's not all that long ago when our lube technicians were considered the mechanical gurus of the facility. And they used precision techniques to inject an oily lifeblood into the assets that were so critical to our manufacturing. And I'm talking about a point in time that predates time-based lubrication. This was before technology, before condition monitoring. These gurus knew exactly when an asset was in stress. Now, times have changed. Our plants have gotten huge and unmanageable by one guru. But these guys, they were the first responders. But it wasn't their job to fix and repair broken assets. Their job was to maintain assets. And that's kind of the difference between then and today. These were the people, they had their finger on the pulse of the plant. They knew when an asset was healthy. And they also had a sixth sense for when trouble might be looming. Gradually, these gurus disappeared and they weren't replaced. Coincidentally, it happened at about the same time that manufacturing industries began making this transformation from time-based maintenance tasks to maintenance tasks that were driven by condition-based evidence. The key word here is evidence. In order for us to do something to an asset, we should have evidence. If we need to align an asset, we should have evidence that that asset needs to be aligned. And we do that by measuring its alignment with a laser, with dial gauges, with whatever your technique. If we need to flush the oil from a transmission or a gearbox, we need evidence that the condition of that oil is no longer suitable to serve the needs of that gearbox. We go to an oil analysis, we do oil analysis or grease analysis, and so on. The fact is that we need to have evidence. 30 years ago, many plants began, or maybe longer, I don't know exactly the timelines on that, but many plants began using vibration analysis to predict when rotating machines might fail. But what they overlooked is what vibration's actually capable of measuring. Ultrasound or vibration measures physical movement of the bearing. If they're predicting the needs of the machine or the needs of the health of the machine based on physical movement and vibration, they've already missed the fact that lubrication has failed. It's actually the earliest signal that bearings are failing because lubrication failure is the first stage of bearing failure. The first stage of bearing failure has nothing to do with the physicality of the bearing. That's later in stage 2, stage 3, stage 4. So we moved to evidence-based condition-based with vibration. But what's sadly ironic is that while the entire industry transformed from performing reactive repairs to evidence-based, data-driven maintenance interventions, the lubrication team was left in the dust. They weren't brought along. They didn't participate. And again, sadly ironic, but I also want to know why. Why wasn't the lubrication team a part of this transformation? Well, the job of the lube technician ended up getting managed away. And in far too many instances, we even saw it disparaged with derogatory monikers like grease monkey. And who wants to be a monkey? Who wants to be termed a monkey? Nobody wants a monkey on their business card. By the way, I happen to believe that monkeys are pretty darn smart. I mean, you can call me a monkey, it wouldn't bother me a bit. What I don't understand is why during this transformation from time-based to condition-based maintenance tasks, that the decision or the culture made the lube technician seem like an undesirable job, especially when lubrication is such an important element to the reliability of our machines. Our emphasis on reliability and asset management today has never been stronger than it has been. It's the next wave of condition monitoring, and the next wave of asset management is this whole field of reliability. Attend a conference or a webinar, and you'll hear more and more about the latest trends, the concepts and strategies for building a reliability program or a reliability team. Heck, you're even listening to somebody right now talk to you about that. I'm not talking about lubrication, I'm talking about asset reliability and asset management. Today, what we see is a flood of new talent going through colleges, going through CJEPs, going through to conferences, and they're all heading into that reliability doorway. And they're all ready to make a difference for our assets. My question is, why is nobody lining up in front of the lubrication door? What happened to our thinking to make it such an undesirable job title? If lubrication is the single biggest factor affecting reliability, why aren't new young technicians knocking on the door of lubrication? And a better question, why is there one door for lubrication and another one for reliability when they should be one and the same thing? Wouldn't we be better if we had one moving sidewalk leading to a wider, all-inclusive door? From my perspective, it's time to knock down the siloed walls that separate the condition monitoring team from the lubrication team and marry them together, because together they can be so much stronger. As John Donne said in the 17th century, no man is an island. As we need to provide these lubrication technicians with modern tools and with modern ideas and modern training and continuous mentoring. They need to be both capable and competent. They need to be able to grease bearings right. But that's not where this story ends. We're going to go a little bit further back in time. I did study history at university long before I got into this engineering related job. Okay, we're actually going to go a lot further back in time. History is either ours to learn or to ignore, but it can't ever be denied. There's a history of poor lubrication practices, and we can date those practices all the way back to ancient Egypt. 4,000 years ago, Egyptian lubrication technicians, they probably weren't called that. If indeed.egypt existed 4,000 years ago, they're probably called something like oil pourers or something like that. And what they did is they used water or tallow or oil or duck fat or some other kind of slippery medium to help lubricate the surfaces so that they could move their sleds along the ground and up hills. And they actually did it based on condition. They actually had evidence-based feedback. Yeah, well, they didn't have data collectors, but what they did is they realized that, well, when the sled became too hard to push, you know, maybe they had to recruit more slaves. They didn't have enough slaves to push that sled. So what they did is they added more oil. They poured more oil underneath the tracks. So they used evidence from the friction created between the sled and the ground. And so what we could do is we could build a flimsy argument around the fact that Egyptians actually invented condition-based lubrication. And then somewhere between 1700 BC and today, we just stopped using it. When non-lubricated or improperly lubricated surfaces come in contact with each other, friction is created. And in many cases, this friction is an energy waster as well as a heat generator. Pouring a steady stream of duck fat or olive oil onto the surfaces in Egypt 4,000 years ago was the best solution that we had. We can do much better today. Times have changed, applications have evolved. Lubricating the bottoms of a sled so it can slide along the ground easier doesn't require quite the same precision as maintaining that thin film of lubricant in a modern day rolling element bearing. But for a sledge or for a cart, too much grease is okay, because the sliders of the sled just squeeze the excess out of the sides. Heck, the Egyptians didn't even have to worry about the EPA coming and inspecting their grounds for contamination. Fast forward to today, we know that when we add grease to a motor bearing until it pushes out of the seals and it drips onto the floor or all over our work boots, is not the best measure of correct grease replenishment quantity, is it? With today's loads and today's speeds, a dedicated oil pouring person is a poor solution. So is using a calendar or an interval calculator to schedule relubrication tasks. 4,000 years and counting, and industry still seeks a workable method to determine when and how much lubricant is required to maintain that perfect separation of surfaces. Well, we can use statistics to frame or suit our inquiry. We can even use statistics to manipulate our inquiry. For rolling element bearings, it's a well-established fact, it's a statistic, that poor lubrication practices are the leading cause of premature bearing failure, that 40 to 80% of reliability issues are rooted in poor lubrication practices. Whether it's from using the wrong lubricant for the right application, whether it's the deterioration of the lubricant, not replenishing it frequently enough, lack of lubricant, too much lubricant, grease contamination, which can begin long before the grease even reaches your plant. As much as 80% of the bearing failures in your facility will be traced back to poor discipline and control over this critical proactive task of lubrication. So one question I would ask is, why do only 5% of maintainable bearings, and when I talk about maintainable bearings, I'm talking about those that we can actually help, those that we can actually grease. 95% of the bearings in industry are sealed for life bearings. Not much a lube tech can do for those other than try to grease them and do more harm than good. I'm talking about the 5% of maintainable bearings that make it to their L10 life expectancy. And the answer is poor lubrication practices, such as the ones I just mentioned. Wrong lubricant, lubrication deterioration, lack of lubricant, contamination, and so on. There's a bigger answer to this question, and it has nothing to do with the grease guy or the grease gal doing their job incorrectly or doing their job without training. 5% of maintainable bearings, only 5% of maintainable bearings make it to their engineered life expectancy because we allow it to happen. We accept it as a cost of doing business because management doesn't see the bigger picture. And because the cost of a failed bearing isn't such a big deal. We don't see the real cost of the bearing. If you're only looking at the cost of a $100 bearing, you're missing the bigger picture. You're missing all of the other costs that go into it. And sadly, a lot of companies don't look beyond the actual cost of the bearing. The cost of the bearing itself is irrelevant. Simple question, another simple question. Why do we lubricate? It seems like a simple question, but when I ask the question, the answers are never always similar or simple. And some might tell me that we lubricate bearings to fight friction, and that's true. We do add grease to an asset's moving parts to reduce friction, but there's much, much more to that. And some will say, Alan, we lubricate bearings to reduce heat in the bearing. That's also true. If you put the right amount of lubricant inside your bearing, you can help keep moving parts from getting too hot, and you can also help the bearing dissipate grease. And by the way, every time you increase the temperature of your bearing by 10 degrees, you cut the life of that lubricant in half. But some lube technicians think that more is better. And so they take it to the extreme, and they add more grease, thinking with good intentions that they're doing something good for the asset. But in reality, what they're doing is they're choking the machine's ability to disperse heat. The real reason to lubricate assets is to form separation between surfaces. This logic applies not only to motor bearings, it applies to the pistons in my father's Perkins diesel engine. It applies to chains on a chain drive. How often have you walked through your plant and seen unmaintained chain drives? Rusty chains, the teeth of the sprocket worn down like little nubs. The primary purpose to lubricate physical assets is to keep moving surfaces from coming in contact with each other, whether it's the rolling elements of a bearing, the teeth of a gear. Because when they do, we initiate failure modes and we shorten the life cycle. Friction is a force which opposes movement between surfaces. Friction increases wear between surfaces. It increases system temperature, and it dramatically increases power consumption, kilowatts, dollars and cents. When we deliver the right amount of lubricant, we create a thin film between two surfaces, a wedge of oil. And for as long as we can maintain that wedge of oil, it protects the asset from wear and heat while allowing it to produce in an energy efficient way. Some lubricants will even offer the additional benefit of controlling corrosion, have additives, and those additives, as they're bled into the war zone of the bearing, prevent rust and acids and moisture attacks. We have to keep our grease free from contaminants, but the very nature of the thickener allows it to pick up dust and grit. Think of the thickener like that yellow sponge on your kitchen sink. When we take that yellow sponge out of its plastic wrapper, it's pristine and it's new and it's beautiful and it can hold soapy water in it nice. And when you squeeze it, that soapy water comes out to where you need it, which is on your dishes to wash them. And there's also there's also, in addition to the base oil, the additives. But that thickener can also pick up and hold dust and grit. So if we allow contamination in our grease, then that contamination is going to be held just outside the war zone and slowly bled into the war zone of the bearing. So proper storage of our lubricants is critical. And clean grease applied properly can actually shield machines from the ingress of future contaminants. So I mentioned the war zone a couple times. So at SDT, we speak about the war zone. It has nothing to do with conflicts in Eastern Europe or anything like that. When we talk about the war zone, we're talking about the region of the bearing where the lubrication mechanism is doing its most important work. The war zone is where the rolling elements meet the inner and the outer raceway and the cage of the bearing, and where the base oil bleeds from the thickener to create that thin hydrodynamic film of component separation. If that's clear, then when we lubricate bearings, and more specifically, when we grease bearings right, we achieve low friction, low temperature, and bearings have the best possible chance to exceed their engineered lifespan. So our goal has to be to achieve that perfect film and then maintain it. But it doesn't last forever. That perfect lubricating oil film is going to break down. If it didn't break down, if it did last forever, well, we wouldn't need this presentation. We wouldn't need lube techs. We wouldn't need ultrasound. We wouldn't even need me. We could simply grease it and forget it. but that's not our reality. Grease is an organic compound. And just like all carbon creatures, including ourselves, grease ages and eventually it dies. Okay, so that's one answer to the question, why do we grease bearings? But there's a higher reason to grease bearings, a more philosophical reason to grease bearings, and it has nothing to do with fighting friction. Proper lubrication removes up to 80% of our reliability woes, which in turn allows our organization to thrive, to achieve its operational objectives. When you ask the CEO of your company, what's your operational objective? His answer is going to be 100% of the time to make my share price higher for my shareholders. That's his operational objective. If you ask the plant manager, what's his operational objective? It's not going to be to create separation of surfaces with a good lubrication wedge. It's going to be to increase my output, or to increase my availability, or to increase the life of my assets, so that we can allow our operational objectives to be met, and ultimately for our CEO to achieve the higher share price. If you want to get the attention, therefore, of your management, if you want to get sponsorship and funding to fix your lubrication problem and to change your poor lubrication culture, then the way to do it is to show them that the real benefit will be to the bottom line of the company. More output, more productivity, less unplanned downtime, fewer angry customers, fewer missed deliveries, fewer parts in the storeroom, less grease consumption, less failed bearings, and a culture of reliability that everybody can be proud of. So when I said earlier that we've been getting it wrong for 4,000 years, that's not to say that calendar-based methods were mistakes of our past. They were the best solution of a prior era. But today, we know better. We have better technology to support advanced decision-making. It's called ultrasound, and it offers us the ability to finally grease bearings the right way. Now, when we look at the phases of lubrication, what happens when we inject fresh grease into a bearing? We have to understand that there's churning and bleeding phases of grease replenishment. And those are critical in tying together the role that ultrasound plays in ensuring that we do this right. And by right, I mean a solution that provides guidance at each step of the grease replenishment task. A solution that will tell us when to grease, how much to grease, which type of grease to inject, because we don't want to mix incompatible greases. I'll talk about that in a second. Which grease gun to use for the injection, because no two grease guns are the same. I'm going to talk about that too. Provide confirmation to the lube technician, and therefore to the reliability team and the condition monitoring team, that the grease actually reached the bearing. Because sometimes when you pull the trigger on your grease gun, the grease doesn't go where you think it's going. And to confirm that the task actually improved the lubrication mechanism, because we know that all too often a PM can make the situation worse, not better. So we want to be able to assess the cause and effects of failure modes. And it's a scientific approach that helps us determine which condition monitoring technology is the best fit for identifying failure modes. And knowing which of those defects can be detected with ultrasound or other technologies can save a lot of time and frustration. There's not much point in using the wrong technology to uncover a defect. Ultrasound allows us to hear above the noise of the factory floor. It screens out the low frequency sounds that we use pre-hearing protection to protect ourselves from. And what happens instead is that ultrasound inspectors hear sounds that are consistent with the machine system defects. And these defects produce ultrasound from three phenomena. The first one is friction. The second one is impacting. And the third one is turbulence. So when we're faced with a decision to make about whether ultrasound is the suitable or the best technology to find a certain failure mode, is ask yourself, is it a fit? If the defect produces friction, it's a fit. If it produces impacting, it's a fit. If it generates turbulence or turbulent flow, it's also a perfect fit for ultrasound testing. You can use this fitness test to make sure that you're using ultrasound on the right failure modes, or to find the right failure modes. And by the way, 95% of the failure modes that can create unreliability in your organization all produce friction, impacting, and turbulence. I want to mention, remaining cognizant of the time I have left, I want to mention just a word or two about training, because training is something that's near and dear to my heart. I'm very passionate about it. I wrote the first ultrasound level 1 certification training for SDT back in 2001. I've been invited to participate on the working groups for ISO 18436-8 as an ultrasound subject matter expert, and to drive forward the future training agendas for different condition monitoring technologies, and I take a lot of pride in that. If we're still asking the question about do we need training, we have a lot of work to do. But there's, as much as I'm passionate about it, there's a bunch of vendors out there, and they're not all ultrasound vendors, there are other technologies too. But they insist that their products, which are disguised as solutions, require little or no training. And they'll advertise these products to you as, you get results right out of the box, or okay, you give it to a grease monkey, give it to a monkey, he could use it. A terrible thing to say. Or give it to a summer student or an intern, and just let them go. It'll pay for itself the first time you use it. These cliches are ubiquitous throughout, and I tell you, it's a terrible sales tactic because it's false, it's misleading, and it's just designed so that they can get a quick sale and then move on to the next customer, and you'll never see them again. If your solutions provider attempts to convince you to buy their equipment because they offer you free training or no training is required, my recommendation to you is to turn the other way and run as fast as you can. Our goal is to create a team of well-trained lube technicians in as short a time as possible. Different condition monitoring technologies have different competency curves, and by competency curves, I mean the time that it takes to onboard a new technician who knows very little or nothing about a technology to the point where they are at a competent level or even an above competent level. Ultrasound has a short competency curve, but machinery lubrication goes much further than just learning how to push the buttons on the data collector or to click your mouse in the software. So beyond the training that we offer and the mentoring that we offer for our Lube Expert system, we also encourage lubrication technicians to go to organizations like the Society of Tribologists and Lubrication Engineers, STLE, or to NORIA, or the ICML, Intercontinental Machinery Lubrication, ICML, and get certifications in machinery lubrication and oil analysis, and really understand this important technology. Once we've created competent lube technicians, we also have to ensure that they're capable lube technicians. And we do that by providing good equipment, good solutions, good training, and transformational culture. We also want to know that they work safely. And so we encourage all of our lubrication technicians that use our Lube Expert device to say, hey, I have the right not to go near a machine that's not safe to approach. Is the coupling guard missing or not bolted down properly, or whatever? It could be any reason at all. Safety is your own responsibility, and whether you make it home from work in one piece or in a body bag is entirely your own responsibility. And we encourage every technician to stand up for himself and say, sorry, no, not doing that if it's not safe to do it. Are all the measures in place to prevent contamination of your grease? This begins in the storage facility, but it ends at the point of application. Contamination can hit anywhere. Is the ultrasound equipment available when it's needed? Is there adequate technology for the entire lubrication team? Because sometimes the ultrasound program takes off and there's just not enough equipment to go around. Were the lube routes created in a logical and an efficient walking order? Or do they resemble my golf game? Now, if you've never, well, I'm sure you've never seen me golf because you'll never find me on the PGA channel. But when I golf, it's kind of, well, I always seem to start in the middle of the fairway and then I hit my ball and then I'm going right and then I'm going left and then sometimes further left and then right again. And eventually I do make it to the green. But when I put my pace walker on, I sometimes walk 10 to 12 kilometers in a round of golf. So I'm not walking the golf course very efficiently. What I recommend is that your routes through your plant have a logical and efficient walking order. And this is something that our trainers and our mentors help you to do because these guys have worked in plants for 10, 20, 30 years. And they're now retired and they're gurus helping you to get the most from your program. Seems like a small point, but I want to make it. This also, so the next few points I'm going to make, and again, I try to educate, I never deceive, and I try not to sell because my whole career has been based on if I do a good job of teaching you what I know, I don't need to sell you. You'll either say, yes, I need it, or no, I don't, and no hard feelings either way. I'm going to go through a few of the features that I feel are the most important things to consider in an ultrasound guided condition-based lubrication solution. And I'm going to go through them rather quickly because I want to leave at least 10 minutes for Q&A, and we are at 3:15, so 15 past the hour. So I have about 5 minutes to get through this. Does the solution that you're going to use for acoustic lubrication remind you to inject the right grease type? We all know what happens if we mix incompatible greases. I have a fairly long story about a summer intern who was told to grease water pumps in a wastewater treatment facility in Southwest Florida. And so he was given graphite grease to grease just the grid couplings. Well, he thought he'd do he thought he'd go above and beyond. And he decided that while I'm there, I might as well lubricate the pump and the motor as well. Needless to say, they had a big job ahead of them to undo that damage. He didn't maliciously try to do bad things. He just wasn't educated. That's why training is so important. And it's also important that your lubrication solution, your lube expert solution, reminds you of which grease type that bearing needs. You should never assume that two grease guns are the same because they're not, even if they look the same, even if they have the same part number, even if they came from the same OEM. Do not assume they're the same. Grease guns have to be validated. Everyone, every single one. And you just do that by, you just shoot 10 shots of grease onto a newspaper on a digital scale. You weigh the total mass of 10 shots and divide it by 10, and now you know on what the average stroke output will be of that grease gun. Why is that important? Because the lube expert solution itself won't allow you to set up an asset until you assign a grease gun to it. And to assign a grease gun to it, you need to tell the software what the output capacity is of the grease gun, so that when you're doing your grease replenishment, you can measure it. You can measure and quantify how much grease was used on that particular task. The speed of the bearing is also critical. And so the lube expert solution wants to know on every asset, on every bearing, what is the rotational speed going to be? And the reason we need to know this is because after you inject grease into the bearing, you have to wait for the churning phase to stabilize. In other words, for all of the thickener to move its way out of the war zone into the cavities of the bearing. And the rotational speed of the bearing plays a factor in that calculation. So when you inject grease with the lube expert, you will have a countdown of 5, 10, 15 seconds, depending on the different parameters, including the RPM. Running speed of the bearing is also critical to calculating the replenishment quantity. I think I jumped ahead of a slide here. Yeah, I did. Sorry for that. So it's also important for the ultrasound solution to tell you which type of bearing is installed in the motor, because when you tell the software which type of bearing is installed in the motor, first of all, now we know whether it's a greasable or a non-greasable bearing. If it's a non-greasable bearing, all we need to do is trim condition. We don't need to lubricate it. If it's a sealed for life bearing, if it's a serviceable bearing, then we want to know the bearing type, because when we know the bearing type, then we know the bearing dimensions. And when we know the bearing dimensions, then we can do the relubrication quantity calculation, which is critical. All right, I talked about the RPM, so I'll jump past that one. Some bearings are fed grease from the side. Others are fed grease through the top, through the annular ring. And that could depend on where the grease nipple is, although I have seen grease nipples for annular fed bearings and the grease nipples installed on the side, which is a mistake. But again, that's why you get trained and that's why you have mentors. The physical fact of which direction the grease flows into the bearing impacts the grease replenishment quantity and is a criteria that our lube expert solution asks for. So make sure that the solution that you're buying does ask for an indication of either annular or side replenishment. You also need to make sure that when you walk into the plant to lubricate, to do your lubrication tasks, that you bring the right supplies with you. Have you ever gone to the grocery store and forgot to pick up milk or bread or eggs or something else, and now I got to go back? There's nothing more frustrating, and that's why we make a shopping list. Well, the software inside the Lube Expert solution knows the grease quantity required for the replenishment. It knows the grease type, and it even knows which grease gun to use. So if you have 100 bearings in a route and 20 of those bearings are due for relubrication, all you have to do is print the shopping list, email it to the storeroom, and when you're walking by the storeroom, your lubrication cart should be ready with all the supplies that you need. So now when you walk halfway into the plant and realize that you have a shopping list and everything you need, you don't have to go, "Oh, I forgot the milk." The lubrication solution is also a communications tool. And so, like the Lube Expert, you need a messaging system that allows the technicians to communicate to the entire reliability and condition monitoring team. For example, why'd you skip a machine? Because it wasn't safe. Why'd you skip that machine? It wasn't running. Why'd you skip that machine? The lube tube was broken. Or any number of reasons. Or if you didn't skip the machine, but then maybe you aborted the lubrication task after the first pull of the trigger because you felt back pressure. Well, if you feel back pressure, you don't continue to lubricate. You message that to the maintenance team, and they go out and they inspect to see if the grease tube is blocked or if there's some other reason why the grease isn't hitting the bearing. The point is that every single action that you take, every single action that you do requires a message to be sent to the team, because we're knocking down the silos, we're knocking down the walls, and we're communicating now as one. Ultrasound assisted lubrication solutions should monitor the change in the bearing's greasing mechanism every time you pull the grease gun's trigger. If you don't have that feedback, you're going to end up over greasing your bearings. If you don't have the feedback on the condition of the bearing, how do you even know that the bearing is due for lubrication? There's a pretty good chance that maybe it's not time because the interval that you've set for your bearing is wrong. The time interval I'm talking about for relubrication is wrong. So if you don't have any kind of feedback about the condition, heck, I mean, a baby tells you when it's hungry, right? It cries. Well, a bearing tells you when it's thirsty, it screams. So listen, measure, and then use that data to determine what you should do next. And the lubrication solution based on ultrasound should also be measuring the lubrication mechanism in real time, and then adjusting the forecasted injection quantity based on real conditions, not on falsehoods or best guesses, but on the fact that today this bearing is exhibiting this much grease. I'm supposed to give it 50 grams of grease. I gave it 20. Now it's quiet. Should I put another 30 grams in? No. Why would you? You've already created a positive impact on the lubrication film. Stop before you make things worse. And since the lubrication technician is already visiting the asset, he's already there, he's already trained, he's already got a quality instrument that can pull data, why not pull that set of data, those readings, and provide them to the condition monitoring team so that the entire team has insights about not only the status of the bearing's health, but how much lubrication was required to restore it to its optimal condition. Now you've got the lube team no longer in a silo, working hand in hand with the rest of the team. And of course, if you don't document the task, it never happened. Your ultrasound assisted lubrication program has to log everything: grease consumption, success or failure of the task, condition of the asset, and much, much more. There is a large community
Great
of
presentation.
lube experts out there. And here's a picture of some of the early adopters, but today we have many, many more of them. And hopefully you're ready to become a lube expert yourself. If it's relative to your job, reach out to our friends at Global Test Supply, and I'm sure they'll be able to help you out. Thanks so much. And Peter, back over to you, sir.
Perfect, thank you. I had a few questions come in that I wanted to ask you. This one
I
is—
stopped in because I was running a bit long there, wasn't I?
That's quite all right. And if anyone else has questions, you know where to put them. So this question is, by using ultrasound, will we be able to get a better idea of the time interval between greasing periods?
No. Well, yes and no. Yes, we can get a better idea about that interval, but one thing I want to make clear for everybody is once you've established a time interval, whether it's 6 weeks, 8 weeks, 10 weeks, don't think of it as something you never have to revisit. That time interval between lubrication tasks is changing, just like the conditions of your bearing is changing. So by using ultrasound, we can determine whether or not the interval that we use today is the correct one. And then by looking at all of the historical outcomes of every lubrication task that we ever do, we can go back and use that data to drive our strategy for the future. So if 6 weeks is the right time today, that doesn't mean that 6 weeks from now, it'll still be the right time. So we have to continuously go back and look at our historical results, our outcomes, to drive our strategy on that interval.
Okay, thank you. The next question is, how do we know how much time to wait for the grease to make its way into the bearing?
Based on the calculations that are made by the lube expert. So we have the rotational speed of the bearing dictates that, the dimensions of the bearing, and And so then really you don't have to worry about it because the lube expert does the rest. When you're in guided mode, so there's a mode, when you're about to do the lubrication, you choose whether or not you want to go in free mode. In free mode, you're just sort of feeling the pulse. You're feeling the pulse. You just have ultrasound assisted ears. When you're in guided mode, you have step-by-step instructions. So if, again, I'll use the 50 grams is the quantity. The first injection is going to be 30% of that. After that 30% is injected, then you're going to have a countdown on the display of the device. 10, 9, 8, 7, all the way down to 1. Then it takes another set of ultrasound measurements. And from there, it determines whether or not the remaining 30 grams need to be injected. So if the first injection was 20 grams of the 50, the next injection might be recommended as 10 more grams, and then stabilization or churning phase, time 987650, another set of ultrasound measurements, and on to the next injection if required. And Lube Expert will basically continue to guide you as long as you're making, with each injection of grease, if you're making a positive impact on the lubrication mechanism, it'll continue to guide you, and it will tell you the status of the bearing's health. And then at the end, it'll just say, okay, it was either a success or a failure. A failure doesn't mean that you failed. It means that the task to restore the lubrication mechanism failed. You didn't fail because you have information. You have information to share with your condition monitoring and your reliability and your maintenance team. I have a problem here that lubrication didn't fix. Not a failure of you. I consider finding a failed bearing to be a success, actually.
Perfect. Thank you very much. So, closing statement on behalf of Global Test Supply University, we want to thank you for attending our webinar today. We hope you found it informative and helpful. Global Test Supply is available to assist you in any way. Just visit us on globaltestsupply.com for anything you need. Through globaltestsupply.com, you'll have access to an entire list of SDT ultrasound products with descriptions, specifications, and manuals. You'll also find contact information in order to connect with us, with one of our technical specialists to help you with any questions you might have. At the end of the webinar, we're going to have a very short survey we'd like you to help complete. This will help us bring new and exciting content to you for the next university training sessions we have. And over the next few weeks and months, visit us on globaltestsupply.com in our training section and see if anything else is interesting for you. And don't forget, we're going to be giving out one $100 gift card to one attendee from today to use on globaltestsupply.com. So thank you very much for attending. And Alan, thank you very much for presenting.
Thanks for having me, Peter. My pleasure.
Have a good. Bye, everyone.